Hi everyone, we are PPG-02. Our project is about designing a PPG-based heart rate monitor and oximeter. I'm Yizhou Jiang.
I'm Haling Yu.
And Zicheng was with us last semester. She contributed a lot to our chip design. Here is our project.
Hi everyone, I'm Haling Yu. Let me briefly introduce our project PPG-based heart rate monitor and oximeter. PPG is a non-invasive optical technique that measures change in blood flow. It uses light-based sensor to detect volume variation of blood, which correlates with cardiac cycle. Signal processing plays a crucial role in PPG system. Raw signal from photodiode are inherently noisy due to motion artifacts, ambient light, and biological variation. To address this problem, we implement filtering to remove noise, amplification to boost the weak heart rate signal, and signal separation into AC and DC. We also apply programmable gain amplifier PGA to adjust signal intensity based on input level. The technique employs two types of light, red and infrared LEDs. They interact with finger to determine heart rate and blood oxygen, and we can use the AC and DC signal to calculate the factor R and use this R to calculate the blood oxygen in this function. Let me introduce the blood diagram of our PPG. The system begins with red and infrared LEDs that emit light onto your finger. The photodiode will capture the transmit light and converting it into current signal. And after the photodiode, we employ transimpedance amplifier. It will convert the small current signal into a useful voltage signal. And after that is the sample and hold circuit. This circuit will stabilize the signal, which can reduce the noise and conserve the power. And after that, we use some high pass filters, low pass filter, and amplifier. This ensure that unwanted noise is minimized and filtered out, which the heart rate signal is amplified. And we also use a peak detector to identify the signal peak, and this peak will send to comparator band to generate full codes for gain control of the PGA. The PGA will dynamically adjust the gain to ensure the signal quality under varying conditions. And the final block is the comparator. It will generate square output that can be easily detected by Arduino. And Arduino will capture the AC output from the second amplifier and DC output from the TIA and use this value to calculate your blood oxygen. Let me introduce our PCB. On the top right of our PCB are the red and infrared LEDs and photodiodes. It is the place for you to stick your finger between the LED and photodiodes. On the left side of our PCB are some potentiometers. It work as the current bias or the voltage reference to generate the current or voltage we want. On the bottom left of our PCB are power supply. We use some batteries to supply our chip. In the center of the PCB are the socket. It is a black box for us to place our chip inside. On the bottom right of our chips are the Arduino circuit. The PCB will send the square wave, the AC and DC component out into the Arduino, and the Arduino will always send the control signal into the PCB, and Arduino will calculate the heart rate and also the blood oxygen. There are lots of SMD cap, which some of them are work as D cap, some are the filters cap.
Here is our demo session. Ijo is now testing the pulse oximeter and the heart rate monitor. He puts the finger between two LED and the photodiode, and now the two LED will take turns to switch on for 20 seconds per cycle. And now we can see the result from the Apple Watch that my blood oxygen is about 99% and the current heartbeat per minute is around 90. It's from 90 to 98. And we can see from the output result for on the computer display that my oxygen level is around 97, from 96 to 97, and my heartbeat per minute is also 92, 93, 96. It is just between the 90 and 100. These are our project. Finally, we want to thank you to our professor Peter Kingen, our TA Alfred Berg, and also our class assistant Jin Yi and Chu Han. And also I want to thank you for all our classmates, and most important, Apple sponsor us for this chip tape out. Thank you so much.